I'm doing problem number 20 in chapter 4 on page 95. And when you look at the problem, right away they're talking about these eye colors and these cats and these different crosses. And they want you to look at this data and say how many genes are involved. Well, when you see this 9 to 3 to 3 to 1 ratio, that's an immediate clue. Because when have we seen that before? We've seen that anytime we have a standard Mendelian dihybrid cross, so dihybrid, two genes being crossed with each other. So we're going to say 2 genes are involved. Then they want us to define some gene symbols. And in order to do that, I want you to again, we've got these other crosses here that give us some information, but start with this 9 to 3 to 3 to 1 ratio. That makes it easier. Okay, so you take this data and you say, all right, whenever I had a dihybrid cross and the 1 out of 16 always had 2 for 2 recessive alleles on both genes, and we can make up whatever letters we want. I'm going to use A and B. Okay, so I'm going to say this must be little a, little b, little b. If I can get this right. Okay, so then we're going to say, how does that work with the other ones then? If I knew the 9 out of 16 was always had 1 dominant allele for each gene. So this has to be a big A and whatever, and a big B and whatever. Okay. So then we've got, what about these other two, these heterozygotes? Well, really what it means is they had 2 recessive alleles on one of them. And so let's look at this one and say, okay, to be brown, you had to have little a, and big B, and whatever on the second allele. You could either have a big B or a little b. And then for gray, you must then have at least 1 capital letter A, and then 2 little b's. So this can become your key. And really, you could have flip-flopped these two if you would have wanted to. It wouldn't matter because you're setting you're labeling these. But if it's 9 to 3 to 3 to 1, it's going to match this pattern. Okay, now that we have set our key, so to speak, and decided there are 2 genes involved, then we can look at part B. In part B, it asks you to look at a cross between a gray-eyed cat and one of unknown genotype. Okay. So I realize it's gray-eyed, all right, so that's got to be a big A, something we don't know, little b, crossed with, again, a cat we don't know. And this is your P generation. My F1 generation is currently unknown. We don't know what that is. Okay. So then my F2 generation, it says the results are the same as the F2 cross in the cross C from the example. Oh, that's that 9 to 3 to 3 to 1 ratio again. So 9 to 3 to 3 to 1. What does that tell me about F1? I only get that 9 to 3 to 3 to 1 whenever I have a heterozygote on both genes in both parents. Okay, so that means we do know my F1 generation. That's got to be big A, big B, little b, crossed with another big A, big B, little b. Okay, so I've got 2 greens, and I get this big variety. And then they ask, what was then the unknown cat up here in the P generation? Well, if I go ahead and erase this unknown mark here, well, that doesn't seem to let me do that. But if we think about it, we say, no matter what, these cats down here got their little b's right here from this parent. That means they needed to get a big B from somewhere. So, okay, we know that there's going to be a big B involved. We also know that we had to get some big A's and some little a's. Well, we don't know that much about the gray parent. So we know she could really be a carrier. Which means he could be anything on that. So I'm going to say that we could have either letter A right there, and I would be fine with that. And I'm going to feel the same way about the second letter here, because we know that we're getting the little b's from this parent. We know that we have at least one big B from this parent to provide there. So really there's a lot of possible cats that could be in that parent generation. So that is problem number 20.